Welcome to Data Analysis with Python. In this video, we'll move on to talk about data visualization with Seaborn. Okay. In the previous video, we had talked about data visualization with Matplotlib, which is said is basic to Python. It's if you're going to take just one visualization tool, one library in Python for visualization, that will be Matplotlib, because even Seaborn is based on Matplotlib. So, and Seaborn provides a high-level interface for creating informative and attractive statistical graphics. So the strength of Seaborn lies in its ability to create statistical graphics, like maybe you're thinking of margin of error, things like line of best fit, margin of error, and things like that. You can get a lot of that with Seaborn. Okay, of course, for any library you need to install, you need to first install, the simple line to install is pip install Seaborn, basically, you know. Of course, because I already have it, then it tells me requirements already satisfied. If you are running it for the first time, it might take a bit of time, but not too much time for sure. Okay. Then the next thing you want to do is to import Seaborn as an SNS as usual. And because Seaborn is based on Matplotlib, you also need to import Matplotlib as PLT. Of course, don't forget the aliases that they don't, you can call them anything, but SNS for Seaborn, PLT for Matplotlib are the most conventional. And then of course, the next thing is to load the data. So Seaborn comes with, interestingly, this is Seaborn, right? Seaborn comes with built-in data sets, which can be loaded using the load underscore dataset function in the Seaborn library. So this function returns the pandas data frame that can be used for data analysis and visualization. So here we are loading Titanic Iris flights and tips data. So I'll just run through their exploratory data analysis kind of. So this is Titanic data set. It contains passengers on the Titanic that sank, I think, in April 2012, 1912 or so. So it has their data like that. Um, let me see. Let me leave this blank so I can know the dimension of the data. Okay, it's not showing that yet. Okay. Is there another way to know this? Let me try print. Maybe print can give it to me. Print and this. Even print is not doing that. Okay, that's fine. Let's just leave it alone. So let me go back to what it was before. So again, this is the code we are running. So I press Control Enter to run it, and you see survived class and all of that. But then we can do other things. Let's see the info about that. So it has 891 entries, 891 data points. That's like having 891 passengers on board or something like that, with all these columns: survived class, P class, sex, age, SIBSP, patch, fare, embarked, where did they get on the ship, class, who, adult, male, deck, embark town, and all of that. So then we can also do the describe for the numerical sites. So the survived class, P class, age, SIP patch. These are the numerical. This is the numerical overview. For instance, you're talking about the age of people on board. The minimum age of the person, or the minimum age of people on board is 0.42. That's the minimum. Like maybe so you had babies on board. That's what that simply tells you. And the maximum was 80. So you had an 80-year-old on board. But the average age of everybody on board was at roughly 29.69. Okay. So like that. So we can also look at the iris data set. The iris in this case is not about the eyes, it's the flower iris, with 150 measurements in three different species. So you have, and then we have the measurement of their sepal length, sepal width, petal width, and species. Then we can get the info. Here we have 150 rows and 5 columns. And here we have, okay, you see, we have 150 entries. So we have 150 flowers for sure, and then 5 columns: sepal length, sepal width, petal length, petal width, and their species. Then we can also describe we can have a statistical overview of the numerical variables. So the minimum sepal length, for instance, is 4.3, as you see here. For sepal width, it's about 2, petal length 1, petal width 0.1, and so on and so forth. Then you have sepal length maximum 7.9, so 4.4, 6.9, and so on. Then we have the flight data set, which we've also used in previous cases too. So it gives us data of 144 data points of number of passengers uh, for an airline every month from January 1949 to December 1960. Okay, so we have the info also. So it tells us we have you know 144 entries and then three columns, just year, month, and passengers. So it's one of the uh data sets we've been using a lot. So you have here, you have the passengers for, these are the numerical stuff here. For year, that kind of math that is not even necessary, but I mean, we can do that still. Then we have the tips data set. So we have like a restaurant or somewhere where people go and they buy. So of course, this is the American setting where tipping, you tip in proportion to how much you spend. Okay. So we have that also. And then we have the tips info uh, so there we have 244 entries and seven columns, and then to describe that. So for total, so mean average total bill spent there is $19.78. Minimum is $3.07, and maximum is $50.81. While minimum tip is $1.1. All right. The mean tip, average tip is like $3. That's 2.99 something. And the maximum tip that anybody gets is like $10. That's like 20% of the maximum total bill, sort of. And then you have the sizes, you know. Then, yeah, let's talk about scatter plots now. So Seaborn provides several functions for creating different types of plots. The scatter plot function is used to create a scatter plot. We can use this function to plot the relationship between two variables. For example, the relation between sepal length and sepal width in the iris data sets. So that's exactly what we are doing here. So, and the keyword here is the SNS.scatterplot, right? And here we call the data by saying iris, the iris that had been uploaded up there before. But I'm even doing that again here, just to be sure. But it's not necessary since we had uploaded it before now. Okay. So, and then you have all of these other parts now. So see what the code looks like. So I just run this and then it produces this scatter plot, which doesn't show any particular pattern. So if you want to know the actual trend here, you may need to go the extra next length of getting the line of best fit, and especially, yeah, the line of best fit will give you an idea of what it looks like. And that's why I went to the next place here. So in addition to just getting the graph right. So we now go ahead to do line of best fit. So by performing linear regression, we have on the x-axis we have sepal length, and the y-axis we have sepal width. The coefficients we do use np.polyfit. So we see numpy is needed here in that case now, right? So now I'm uploading the iris again just to be sure, like it's not necessary for sure. So and we have all of this place to perform the regression, and then in line 24 we now talk about the line of best fit. So this is what we have now. So we have line 24 and line 16 to 21. That's where, because we need, since it's not so clear what the trend is, the line of best fit is going to help us get a better idea of what's happening here. So I run this and see what we get. So, I mean, you could have thought about it in any way. Like it was looking like you could get a line rising, but then the actual trend is, this is falling, right? So it means that there's a negative correlation, though it's not steep, between sepal length and sepal width. So it means that the higher the sepal length, the lower the sepal width. Though it's not so. Now you can see it's described by this line of best way, y equals minus 0.06 x plus 3.42, like that. Okay, so we can create a scatter plot also of sepal length versus sepal width. And then we label. Oh, here. Oh, sorry. Here I'm using the Titanic now, and I'm just using. So we are creating a scatter plot of age, age versus fare, age versus fare for the Titanic data set. Okay. In that case, we have this. Okay, so I mean, this is not neither here nor there. So it's like, uh, because we have fixed prices or something like that. So we don't see any particular trend here. So maybe, this kind of data set, uh, things like regression may not be the best for it. Then we have line plots. You can do line plots also. So the line plot function is used to create a line plot. We can use this function to plot the relationship between two variables over time. for example, the relationship between air and passengers in the flight data set. Now, when we were to do matplotlib, right? To do this line plot, we just needed plt.plot, right? And then you'd have the line plot done. But here it has to be Seaborn dot line plot. Seaborn being SNS in this case. That's the alias for that. So I'm bringing back all this. It's absolutely not necessary because once you import it once, you can always use it. But I just keep doing this to be very sure, especially when I'm teaching newbies in this. Okay, so we want to have a line plot where X is on the horizontal side while passenger is on the vertical side, and you have all these labels here: X label, Y label, the title, and then we show the plot. So this is now see what it is now. So now the beauty of Seaborn is that you now have a kind of margin of error. So you have the normal line, and then you now have the margin of error, which we didn't have in Matplotlib. So that's the advantage of Seaborn over Matplotlib, right? So we want to create a line plot um of okay before it was passengers over time. So we are saying P class P class over age, So what are the P classes for the ages? So that's what I want to do here. So for now, I mean, this is all over the place, so it's not so pretty. So it means like your data determines the kind of thing, the kind of plot you will use. So obviously, line plots will not be the best for this Titanic data set. If you are looking at these two variables, so you can see like as we go on, you are going to see better other plots that are better for the Titanic data set. So most of the points are actually categorical. So you may need to do some classification, like you may need to do histograms, box plots, and stuff like that. So then we have line plot here. We are creating a line plot of sepal length, you know, sepal length versus sepal width. Sepal length versus sepal width. Okay. So this is what we get. Okay, I mean this is also not looking too good. Maybe there are better ways of doing this. Now we have come to histogram. You see that histogram is better suited for some kind of data sets, especially the Titanic data sets, because you have mostly categorical variables. So the hist plot function is used to create a histogram. We can use this function to plot the distribution of a variable, for example, the distribution of sepal length in the iris data set. So look at it. So create a histogram of sepal length, just sepal length. We want to see how that looks like. So look at the code. So for the histogram, so this is for sepal length. Now that's the distribution. So you can already see that the mode is like between 5.5 and 6.5 like that. So yeah, we can do the same for the iris data set. Oh yeah, we're still talking about the iris data set. Now we want to add some color to it. We want to distinguish the colors, so to give more information. So it's like the same thing we had up. Okay, maybe I think this is different now. So this is up there, it was sepal length. Now we're still looking at sepal length here, but we're differentiating by species, right? Um, so here, if in each bar you can see the composition. So for sepal length of 4.5, everything seems to be setosa. When it comes to the ones with 5.0, so you have mostly setosa and then a bit of virginica and some vesicola. So for sepal length between 5.5 and 6.0, you have mostly vesicola, and then you have some virginica also, and so on and so forth. So I mean for the very long sepal lengths, they are mostly virginica, right? So you can add some color thing to that. So then we can come to the histogram of sepal of passengers in the flight data set, right? So that's what this is about here. So and then we do all of that. So hist plot is still what we're using. So we have it. So course for 100 passengers, you have we are counting, right? So the peak mode of passengers would usually be when you have 200, right? That's the most common. So I think that talks about the plane that is being used. So planes that can carry 600 are very few, maybe just one or so in the whole airline. All right. Then we can also distinguish by month, and that's why we're adding the hue factor there. So you have the histogram plot of the flight data for passengers and distinguishing by month. So here we can see that. So the 600 passenger stuff actually flies around uh June, July, August. In summer, I mean, for obvious reasons, because that's where you have the highest number of traffic. So that's one insight you can draw from that, right? So for others, right, you have like for passengers around 100, 200, you have mostly that happens a lot in February and January and February. So you can see the month trends even in all this. Okay. So then we come to want to create a histogram of age, all right? Age in the Titanic data set, with P class, we want to distinguish according to the P class, right? So in most of the places, right, in for people from age 20 to like 30, they are mostly in third class. Like it's more like the kind of ticket they carry, right? For most of the people in first class, they are like well older in a way, older like that. So we can distinguish that. So you have bar plot also. The bar plot function is used to create a bar plot. We can use this function to create the values, compare the values of a variable across different categories. For example, the average total bill for different values in the tips data set. Okay. So now I'm loading the tips again, which is not necessary, just like I keep saying. So here I want to create a bar plot of total bill by day. All right. So what is the total bill from Monday to, I mean, Thursday, Friday, Saturday, Sunday, according to the data set. So you see you have the highest bill comes in on Sundays. Of course, maybe people just go out and just have they hang out on Sundays just to relax. Saturday is next to that, and then you have Thursday is more than Friday. So that can make you also think that, oh, probably the location of this place, there's something special about Thursdays that makes this actually happen. Okay. I remember going to Korea and my friend was telling me that they have Wednesdays is when people really hang out in bars and things like that. So maybe this kind of bar will make you curious that what's happening. Why is Thursday more than Friday? Could it be about something special about Friday? Because you'd expect that Fridays more people should be out on Fridays. I've been the last day of work or so. Okay, so we can also do a bar plot of the P class by fare. So what's the P class by fare? So bar plot, since you have mostly categorical data, so this can give you more insight. So you see, you have uh the fare. So first class, of course, you expect the fare for first class to be higher, to be the highest, in fact. So the fare for first class is above 80 pounds or whatever was charged, and for class two, it's lower, and class three is really low. So you get the fares according to the passenger classes, right? Then we can add. So here we are creating a bar plot of Embark Town. That is the town that people got on the Titanic ship. Uh, then you want to categorize that by the fare that they paid. So this is what that tells us. So people that got on in Southampton, they don't pay as much as people that got on at Cherbourg, and they don't pay as much as people that got on at Queenstown. Probably I mean I don't know so much about the Titanic ship. I mean the details, but this graph, I mean this plot can already give me an idea that probably the train, I mean the ship started out in Cherbourg, and then the next set of passengers were picked up from Southampton, and the last set were picked up from Queenstown. I can already, infer that from here. I may be wrong, but with a level of assurance, I believe that should be true. Okay. Then here we are talking about a bar plot of the embarked town by age. So how did they get on by age, right? So the embarked town by age. So this can help us see each town, the towns where we have the oldest people, the youngest people, and things like that. So here now, you see that the Southampton has, okay, Cherbourg has the oldest people on board, right? And followed by Southampton and followed by Queenstown. So the oldest people on board, of course, the ages are not so different like that, right? But the oldest people on board are from Cherbourg. That's what this is telling us. Okay. And we can also do the same for the iris data set where we look at we want to create a bar plot of species by their sepal length. Okay, so we want to see which species have the longest sepals or the shortest sepals and things like that. So we can infer that from here. So so we see here that Virginica species has the longest sepal length, followed by Vesicola, followed by Setosa. So these are the kind of things we can draw from here. So here again, we want to create a bar plot of species by petal. What we did here, there was petal sepal length. So we can do the same for petal length. Of course, I have reasons to believe that those lengths will be proportional somehow. So there's every likelihood that the Virginica still have the longest petal length. I mean, by hypothesis is cool because I believe, I mean, in plants, right, there's a level of proportion. Like the taller you are, the longer your hand will be. So based on that, I can imagine that that is what is going to happen. So we can also create a bar plot of the months, months by passengers. Okay. Okay. So what does this tell us? It tells us that the months where we have the highest number of passengers, of course, like we've seen in other places, it's usually July, August, right? June, July, August. With July and August are almost head to head. Like that's active summer where people are flying all over the place, traveling and everything. Then we can also create a bar plot of total B by, oh, sorry, this is the flight data set. I just copied and paste previously. So we can create a bar plot of year by passengers. So here we are going to see, or do we have more passengers flying as the years go by or less, or there's a plateau? I mean, for obvious reasons, more and more people kept on embracing flying over the years. So you see constant increase. Well, you see increase, right, from 1949 to 1960. So more and more people embrace flying. So we have box plot. Box plot, we had encountered box plot as a very powerful tool for, you can easily see outliers when you use box plot. So the box plot function is used to create a box plot. We can use this function to visualize the distribution of a variable across different categories. For example, the distribution of total before different days, for different day values in the tips data set. So here now, we want to create a box plot of total bill by day. So X is your day, then total bill, like that. So we can get the box plot when we run that. Okay. Now you see that uh, the median, the median total bills, the highest median total bill is on Sundays, like we saw before, followed by Saturday, followed by Thursday, and then Friday. Now, when we talk about outliers, these are actually outliers now. So the people on Friday spend, but I mean the distribution for Friday is wider than that of Thursday, right? But on Thursday you have a couple of outliers that are outside of the box, like maybe some very big spenders, even on that Thursday, right? So on Friday you have if just one outlier here. So these are outliers. It can be at the top or at the bottom. Like maybe these people spend way more than what most people spend on each of those days. That's one thing that box plots help us with. So we can do box plot for the Titanic data set where we create a box plot of fare by passenger class. Okay. So see this now. All right. So I mean, passenger class one, that's like first class, right? But then even as expensive as the ticket is for that class, you still have many people who went. Maybe they wanted premium luxury and they paid way above £500 or whatever they were paying, right? So of course, for these other ones, you still had maybe people that got on in last minute. Just like when you're booking flights, right? The closer you are to the time of the journey, the more expensive it will be. So maybe that's why you have a few outliers for the two other classes because their ticket price is a bit, I mean, way lower than what you had what you have for first class. Okay, so here we have box plot for passengers categorized according to month. So it's like what we saw before with bar plot. So like quite intuitive like that. So we also have here, want to create a box plot of sepal length by species like this. Okay, so we've seen something like this for Virginica. So now for the first time we are seeing an outlier on the low side of things. So for Virginica, they have the longest sepal length, but then they have maybe some outliers. So outliers should make us curious. You may want to wonder, why is this happening? Could it be that this measurement taken was taken in a particular location where there was a particular challenge at that point in time? It could just be so. Outliers should make you curious, right? Then we have heat maps. Now, heat maps are like what do we call it now? We've talked about regression. What's that thing now? Scatter diagram. So heat map is just like uh and what's one thing scatter diagram helps us with is regression, right? How one numerical variable is related to the other. So heat map is like regression on steroids, so to speak. Like you want to see all the numerical variables in a data set. You want to see how they connect at the same time. So you don't have to keep doing regression separately, like correlation. You don't have to do the computation separately. You can see everything just in one place. So here we are using the iris data set, right? So for the numeric columns, now we're changing them to float and integer and all that. Okay. So that we can easily do the correlation. And some may not be necessary, you may have to drop them. So, and the key thing here is where you have this numeric columns dot correlation, because correlation only works for numerics, right? It doesn't work for categorical variables. So if you run this now, see what happens here. So you don't care about the diagonal, because the sepal length and sepal length will give you a perfect correlation, but so it doesn't, we don't worry about that. We so worry about others. So now this bar is telling you that the redder the better, the redder the more highly correlated, the bluer the more negatively correlated. So from here now, looking at the figure 0.96, 0.96 tells you that you have the strongest positive correlation between petal length and petal width. So that means that the longer the petals, the longer the petal width, the longer the petal length too, right? So for negative correlation, the stronger negative correlation is this minus 0.43 between sepal length and petal width, sepal width. So it means that though it's weak, right? It's really weak. It's not that effective. But what that simply tells you is that the longer the sepal width, the shorter the petal length, something like that. Okay. So we can also do this for tips as we look at I mean, it happens for all numerical variables. So the most positively correlated, I mean, everything is positively correlated, but the strongest is 0.68, right? Where tip and total bill are the most highly correlated, and and of course it really makes sense because the higher the bill you're paying. For instance, if you have to pay 20% of whatever you buy, so I mean that strong correlation it can be taken for granted, right? So the higher purchase, the higher the amount of stuff you buy, the higher the bill. I mean the tip you pay, right? So we're doing this now for the Titanic data set for just the numerical columns too. So here, most of the most of the columns are, most of the variables are categorical, even if they look like numerical. So heat map may not be so nice for this one, but I mean I just did it for the sake of it. So then we have some very beautiful plots in Seaborn, right? Like you have you can have pair plots. So the pair plot function is used to create a pair plot. We can use this function to visualize the relationships between different variables in a data set. For example, the relation between sepal length, sepal width, petal length, and petal width in the iris data set. So this is more like a heat map that is, but in terms of pair plots. All right. So the first we do for iris, and the next we do for uh tips. So I run this, and then it gives us all the pair plots, so all the possible numerical stuff. So you see this now. So you can see so you have scatter diagrams, and you can see the correlation. So we see here that sepal length and petal length. Okay, I think we don't take things on the diagonal. We don't care. So sepal length and petal length. I think that was what we saw before as the most positively correlated. So you have all these things. So we can also distinguish them by species. So this is pair plot right here. So I mean, it all depends on how you want it to be. So for tips, we have the same. We can do the same for tips data sets. We already know that tip and total bill are the most correlated. The other things don't give us too much information because there's no clear correlation like that, right? But you can see a kind of positive rise. As tips rise, total bills rise. As total bills rise, tips rise. I think that's more like what the idea is. So the violin plot function is used to create a violin plot. We can use this function to visualize the distribution of a variable across different categories, similar to a box plot, but with the added benefit of showing the shape of the distribution. So the bulkiest part of the distribution shows you where you have the highest concentration of whatever we are measuring at that point in time. So we want to create a violin plot of total bill by day, for instance. So you use SNS of violin plot. That violin plot is a function inside the Seaborn library. So here we want to see the violin plot of total bill by day. So of course all the other labels are there. So if you run this, what does this tell us? Okay, I mean everything looks about the same, but it looks like this Friday. So in on this Friday now, so this place that shoots out the best. If you trace it down, it means that most of the bills people pay is around between 10 and 20 for this Friday. So there's no, all of them look a bit about the same, but okay, yeah, Thursday is pretty wide. So people pay mostly around $15. You know, that's why you have that shape really shooting out at that point, even for other days too. But it's particularly significant for Thursday. So create a violin plot of total. So here we are saying total. Up there it was total bill by day. Now it's going to be passengers by month. Passengers by month. Passengers by month. Okay. So yeah. So most of the distributions, uh, so so you see 200 passengers is more most of the most of the planes, right? Or most of the yeah, most of the months have 200 passengers on the average, except, things get narrower around here, you know, so like that. Then you can also have joint plots. Joint plots. The joint plot function is used to create a joint plot. We can use this function to visualize the relationship between two variables along with their distributions. Okay, so yeah, visualizing the variables, you're also seeing their distribution at the same time. So we want to create a joint plot of sepal length and sepal width in the iris data sets, and you just say SN as a joint plot. Data set is iris, the x-axis is sepal length, y-axis is sepal width. So this may not be so interesting, right? Like, I see scatter plots there already, and I see things like histogram. So it may not be so interesting. But I mean, your data set will determine the best plot for you. So, and as you play with these things, you may fall in love with some particular kind of plots. So which is good for your own data set, right? So you have the KDE plot function, which is used to create a kernel density estimate plot, which we can use this function to visualize the distribution of a variable similar to a histogram, but with a smoother curve. So you now need a curve, maybe like that connects maybe the centers of each bar of the histogram or something. So you can create a KDE plot of sepal length, for instance. So and the Y label tells you about the density. So you have histograms, right? But then you have the lines passing through the histograms. In that case, so we're doing the same for here. We're doing the same for passengers in the flights data set. Okay, the flight data set. So something like this. So it all depends on what you want to see, what you really want to see. Then we have the swarm plots. The swarm plot function is used to create a swarm plot. We can use this function to visualize the distribution of a variable across different categories, similar to a scatter plot, but with the added benefit of avoiding overlapping points. So here we don't want points to overlap. That's the advantage here. So create a swarm plot of total bill by day. So say SN is the swarm plot, data is tips, X is day, Y is total, and we are distinguishing it by day. So I particularly like this plot. I think it's beautiful, right? So it tells you, um, of course, you can see the highest bill for any days on Saturday. So this one you have a continuum instead of like the box plot with outliers. So you have everything going without overlapping, right? Like that. So we can do some plot for what did we have up here? It was total bill by day. So now we can have so this will be passengers by month, like we've been doing before. Passengers by month. Passengers. Passengers. Passengers by month. Okay. So I mean, this is not this is not looking too nice. So it may not be the best kind of thing for this, but maybe you can still can still help to draw some insight, right? So maybe if we add a hue to it, if I add hue, if I use here as hue, maybe that can make it a bit more interesting. So this is equal to year. So we okay, it doesn't help so much, but it's okay. Right. So we here we're doing we want to create a swarm plot of sepal length by species, sepal length by species, and we still distinguish by species. The color by species, right? Special sepal length by species, and we still distinguish by the species. Okay, so I mean this is cute also somewhat. Then we can have facet grid. So the facet grid function is used to create a multi-plot grid where each plot represents a subset of the data based on one or more categorical variables. We can use this function to visualize the relationship between different variables in the data for each category. I mean, this is still sounding like heat map. So heat map can easily take care of all these things. Okay. So, but the only benefit here is that now instead of having everything lumped together, you're now seeing the relationship between total bill and tip at the day level. Okay, so that maybe the facet grid can be really useful in that regard. So it's more like you are drilling down into the data. So of course, we've seen the relationship between total bill and tip overall, but here you are drilling it down to the level of the day. So that I think that's the advantage of facet grid. So if you want to drill down and see what's happening, even at some finer levels, that can help. So you have the count plot. The count plot function is used to create a bar plot of the function of the count of occurrences of categorical variable. We can use this function to visualize the frequency of different categories in a data set. For example, the following code creates a count plot of the sex variable in a titanic data set, right? Like this. Okay, so this is histogram or bar can easily do this, so not a big deal. Then we have the pair grid. The pair grid function is used to create a multi-plot grid where each plot represents a pairwise. Now, this is still sounding like it's still giving some heat map vibes. So, not, but you may just prefer to see it this way. So, not a big deal still, if you ask me. But if you just like the graphics, you may want to go for pair grid example. So, not a big deal, really, if you ask me. So the cluster map function is used to create a clustered heat map. So we can use this function to visualize the similarities and differences between different variables in a data set, as well as the similarities and differences between different observations in a data set. So it's like we are drilling down to some level. Yeah, this will be particularly useful. If you want to see like you want to see different variables at the same time, like even in 3 dimensions. So here we are seeing year, month, and the density kind of, right? So that's what is happening here. So I mean, I particularly like it for the beauty too. So I think the ecologists like this kind of graph a lot. So cluster map. So if you want to use cluster map, if it works in your field, if it works in your field. So here we can see the year, we can see the month, and then the points, the colors tell us, the how concentrate the density of what's happening. So here now it's like you're still drilling down at the same time. So imagine this is we already know that the biggest flights are around July, August, June, July, August, and so that's like where you have the highest number of flights, right? So you can see that the reddest parts are in August and July. So June is high to ball. July and August are like the big deal. So, but things become pretty light around December, for obvious reasons, winter, right? So October, December, like that. So I think this could also be very useful if you really want to, like, you want to drill down, you want to zero in into the data and see things you want to see specific months and specific years or something. Then we also have point plots. Point plot. The point plot function is used to create a point plot. We can use this function to compare the mean value of a variable across different categories. So here we are doing total bill by day and sex. Okay, so we have point plots. Yeah, this is also useful in the life sciences, I think. So you can see interactions and things like that here. So we have point plot. So you can compare two. So we are doing a total bill by day and sex, right? So on Friday, you have total bill by females are really low and it's high for male. So I mean, for female is low all the days, but on Fridays the gap is wider. So that's one thing you can draw from here. So here we are doing So up there it was total bill by day and sex. Here we can do passengers, passengers, passengers by year and month, by year and month. Okay, so that's what you have right there. So we can, so here we're doing sepal length or petal length rather, petal length. We're doing petal length by sepal length by sepal length and species and species. Okay. So that's what we get. Yeah, not so much information here. So one thing you get used to is you choose what works best for you and use it. So what if we want to do multiple lines, right? The line plots function can be used to create a line plot with multiple lines. We can use this function to visualize the change between one variable and another. So this is still doing like a heat map. I mean, for the tips data set, it's not too pretty. So let's talk about how to save in Seaborn. Now, since you already know that Seaborn is based on matplotlib, so we save exactly the same way we save in matplotlib. And what is the dependence of Seaborn on matplotlib about, right? Seaborn can do all the beautiful graphics, but when it comes to showing the graph, like titling, so from here now you can see Seaborn is good because it has its own data set. You can get data set from it. It's also good for the scatter plot in this place, which will be probably more beautiful than what you get in matplotlib. And then to now title it or to save it or to show, you need matplotlib. So that's where matplotlib comes in. So Seaborn will draw the graphics, but matplotlib will help you to visualize, to title, and do all other things on it. So see, that's why Seaborn cannot stand alone. So we have this now. So I have saved this now as Seaborn plot. So if I go into the folder, then I can find that. Okay, Seaborn plots. That thing you just see now. Where's it? Seaborn plot. This. So that's that now. Okay. Yeah. So as an assignment, right, if you want to try, get an external data set of your choice. Now, with all the, I have my own data sets, which you can access via the description box, either on Facebook or on YouTube. So you can pick any of the data sets I didn't use there. All the data sets I used are actually inbuilt in Seaborn in Python. So you can use those external data sets and try your hands on them, try different things. You can just copy this code exactly, just change the data sets and tweak stuff and see how things go. So you can take this for an assignment right now. So you get an external data set of your choice, perform some exploratory data analysis to understand the data, clean up the data if necessary, get some descriptive statistics, visualize the data in the ways most suitable for the data type. Now, from what you've seen, right, you see that the Titanic data set has mostly categorical data set. So doing things like correlation and all that may not be the best for them. So it's better to categorize in those cases, like using box plots, bar plots, and all those. So you can also state 5 conclusions from your analysis. As I was showing all those things, I was drawing insights from them. So you want to do the same as much as possible. So we come to the end of this video here. Let me know how helpful this video is for you. And if there's a topic you'd like me to teach, or a problem you'd like me to solve, or you have a data set you'd like me to work with, or you have a data set you don't even have, but I mean, you can just give me the idea, then I can generate it. I can just make up the data set and work with it so you can have an idea, have more insight into that which you want to do. And don't forget, all the data sets I'm using, they are you don't have any problem getting data sets, right? Because the data sets I'm using are inbuilt in Python, or I have them for you that you can access them. So don't forget, if you have not subscribed to the channel, of course, you are missing a lot already. And if you have subscribed, don't forget to hit the notification bell also so you can always get alerted each time a new video is released. Be sure to like and share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing data right. Bye.